Hello and welcome to Project Infinity. Today I've made a video to show you how I built an aluminum and brass pen on a mini lathe. This is a really great project for beginners to learn different concepts on the lathe, and you come out with a nice shiny pen at the end. There are a lot of different components involved, so you'll learn different techniques in the process. Here's the schematic of the pen that I designed. This is all built around the Pilot G2 ink cartridge. I can provide a link to that in the description so you can purchase that if you're building the pen as well. So it's really nice because the pen's available pretty much everywhere and you can find refills really easily and it's very cheap. So I'll get right into how I made the pen. Okay, so the first thing I'd like to mention is for the pen tip. It's actually an improvement on what I did in the video. This is the schematic for what I did in the video, and you can definitely follow this. You'll have a nice working pen in the end. The only issue is that the tolerance for this bore here, when the ink cartridge comes in and protrudes out, it's a little bit of a large tolerance, so it moves around a little bit and it feels a little boggy when you're writing. So what I would recommend if you wanted to is exchange A for a size 38 drill bit, and that'd be a much tighter fit, but there's a little plastic sleeve around the ink cartridge, which is why I use the 30 in the first place, that you'll need to accommodate for. So you could drill through with the size 38 drill bit, and then from G here, you want to use a 30 drill bit to drill in another 1/4 of an inch. Or from the face of the work, you can drill in 0.75 inches with a size 30 drill bit, and again, exchange A for a size 38 drill bit. So that'll be a perfect tolerance for the ink cartridge, and you won't have any wiggle there at all. But like I said, you can definitely just leave it be, and you won't really have any issue at all. It's just a slight improvement. I made 2 separate components with the pen grip and the pen barrel, mainly due to their lengths. The length of the pen barrel is 3 inches, length of the pen grip is 2 inches. So with my drill bits, you can only drill in about 2 inches, so you'd have to drill in from one side, drill in from another side, and I still wouldn't make it all the way through. So I made these into 2 separate components. It's also nice to have a different pen grip if you wanted to change the style or something of the actual grip here. I didn't put it in this illustration, but in the video you'll see I made a few little notches on the sides just to increase grip and have a nice aesthetic finish. Otherwise, with the pen barrel, just make sure to note that these are 2 different thread diameters. The G is a 3/8 inch by 24 TPI, and H is 5/16 inch. Both fine thread. Just be aware it'd be crappy to make this piece and then didn't see the difference there. But the cap and screw, so essentially how this works is the screw is a set screw that screws into here, and you have to adjust the length accordingly for the ink cartridge. I'll show you in the video, but you put the set screw in here, and then it protrudes out, and then this protrusion screws into this side of the pen barrel. And then the tip of the set screw actuates the pen cartridge. So as you screw in the cap, then it pushes down the ink cartridge, which pushes it out the tip. So it's the actuating mechanism to protect the pen from writing if you have it in your pocket or something. And technically you could just use the set screw and then just screw it into here, in and out, but then you just have like a threaded set screw like sitting out of your pen, which isn't very pleasing to look at. So the cap just makes it look nice. But it's also nice to, once you set the actual length that the set screw protrudes, you'd want to use something to hold it in place, just Loctite or something like that. So before we move on to the actual video and turning, I'll just zoom in on these pictures so you can see these in a little bit better detail. So feel free to pause the video on any one of these to get a little better view, but here's the pen tip. Here's the pen grip. Here's the pen barrel. And the cap and set screw. Here's the bar stock we'll be using to make the pen. The top is 1/2 inch aluminum round. The middle is brass. It's 3/4 inch. You can definitely use 1/2 inch, and I would recommend it. None of the outer diameters of any of the components of the pen exceed 1/2 inch. I just had 3/4 inch on hand. In the bottom, you see the Pilot G2 pen that we'll be using, the ink cartridge from, and the spring. So starting out with the grip, you can see I'm doing a facing cut here and center drilling. If you notice on the bottom right-hand side of the screen, I put the schematic of each individual component as I'm working on it. I also highlight the letter of each individual process I'm working on, just so it doesn't get too confusing. A lot of the processes can look pretty similar. And I also sped up the video quite a bit because this video would go on forever if it would probably be quite boring if it was at normal speed. So apologize if it gets a little jumpy in places, but just try to squeeze it all into a manageable amount of time. Also, if you're interested in learning more about how to use the lathe itself, I don't really go over that too much in this video. It kind of just assumes you already know some of the basic processes. But if you do want to learn more about how to use a mini lathe specifically, I'd strongly recommend checking out Frank Hoose's channel on YouTube. It's full of awesome content. It explains every operation you can do with the mini lathe in quite a bit of detail. He's a pretty good teacher in that aspect, so I'd recommend checking that out. One really handy tool that you can use in this type of project is a tap follower. It uses your tailstock and holds your tap in alignment with your workpiece. So as you start the tap, it's not canted when it goes into the bore. So it's really helpful keeping things in alignment. And although you can tolerate a little bit of a wobble, as I'll explain later, you can correct for it a little bit. It's just really nice for projects like this where you want to keep as close to perfect alignment as possible. So as mentioned before, the tap follower is a really nice tool to have for this type of project, but so is this. This is a die holder. It performs pretty much the same task. It just uses the tailstock of your lathe to hold your die in alignment with your work. So when you start the threads, it's not canted, and it makes really nice threads. You can purchase these online, but they're extremely expensive. So if you wanted another fun project, you can turn this on the lathe. I turned both this and the tap follower on this lathe, and they turned out really well. I use them every time I'm cutting threads, so it's very nice to have. So you'll see in a moment, I ended up using a 1/4 inch end mill to drill the C diameter. And the reason I wanted to do that was to create a flat shoulder for the ink cartridge to rest on when it was fully protruded. I didn't include that in the schematic. If you don't have an end mill, no need to do that at all. The eye drill would work perfectly for that. But actually right here is the issue that I had that I mentioned in the beginning. I drilled straight through with the size 30 drill bit. So you can see when I test fit the ink cartridge here, there's a little bit of a wobble there. And it's just that gap is just large enough that when you're writing, it creates a little bit of bogginess, which works fine, but it's a little annoying. So I'd recommend using the size 38 drill bit instead. Okay, another note here, if you look closely after I flip around the piece in the chuck, you'll notice there's a little bit of a wobble. So that's important to note because that's really the main difference between using a self-centering 3-jaw chuck and 4-jaw chuck. 4-jaw chuck, I could have used a dial indicator and dial the center back in. Once you do work on a piece and then take it out of the chuck, you lose that alignment. So when you put it back in, there will be a slight wobble. But I'll show you in a moment how it doesn't really matter in this application because you can correct it just by turning it down. So as mentioned a moment ago, this is how you can correct for that wobble or run out after switching back and forth in the chuck. So you notice the tailstock there has a live center, and now we're turning between centers. So this is a technique. It'd pretty much be impossible to turn this long of a piece because it bends with pressure from the cutting tool. So as you turn across centers, notice that wobble pretty much disappears because we're creating a new center by making each of these individual pieces turned together as one. So you can see here I was using a file to form the tip freehand. I quickly gave up. My file was pretty dull. I probably need a new one, but I ended up turning the carriage on an angle and turning the pen tip and shaping it this way. It worked a lot easier, and I think it ended up looking more professional in the end anyway. As a word of caution, you'll want to be really careful if you decide to cut in any grooves in the grip. With the size 38 threads, the internal thread's major diameter is really close to the overall diameter that you turned the pen down to. I turned it down to 0.443 inches, and that only leaves 68 thousandths of an inch. So be really careful. You don't want to cut right through your pen at this point. So just cleaning the end of the pen barrel and adding a little chamfer. Onto the pen cap. This part can get a little bit complicated with all the processes. It goes a little quickly, so it's really helpful to follow along with the little highlighted letters at the bottom right hand there. This worked out really well. This aluminum piece here was actually used as a holding jig to hold the pen between two centers when I was turning it down previously. But I realized that this thread is identical to the thread that I'll need for the set screw. So I just turned it down and increased the length of the thread there, and I could use it to hold the pen cap as I turned it down further. And eventually you'll see I just cut it to use it as the set screw. So very handy piece there. So this is pretty much the worst way to make a groove for a flathead screwdriver, but I have the Dremel, so I use that, and it got the job done anyway. Ideally, you'd use a hexagon rotary broach, so you can twist this with a hex key. The spring that you see here is also from the Pilot pen. Make sure not to throw that out when you're taking the ink cartridge out and dismantling the pen. And after some finishing and assembly, here's the final product. I probably could have done a little bit better job on the finishing after seeing the close-up pictures here, but it's never really been my forte, and I'm pretty happy with how it turned out. As I mentioned in the beginning of the video when we were going over the schematic, the set screw can be a little bit finicky depending on your final dimensions. I got lucky where when I set the screw fully into the cap, its length extends the ink cartridge out to the desired writing length when you turn the cap. If your final lengths were off somewhere and the ink cartridge doesn't fully extend, then you can just adjust how far you screw the set screw into the cap and then use some Loctite to hold into place when you get it to actually work properly. So overall, I'm really happy with how this turned out. It was a really fun project to make it, and it's always good to hone the skills on the mini lathe. And if you followed along, hopefully it was easy enough to follow, and I hope you had fun as well. Don't forget to like and subscribe and follow along for more content. I'm planning on making a lot more videos, not necessarily based on mini lathes, but overall just science experiments and a lot of projects that keep me interested and hopefully keep you interested as well. So thank you very much.